I am Dr. Mohammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today I want to discuss about network programming and management of the subject content TCP and IP protocol. Overview of TCP IP protocol. Internet protocol, that is IP. Internet the protocols are a set of rules that governs the communication and exchanging the data over the internet. These internet the protocols can be framed with a set of rules and regulations. Both the sender and receiver should follow the same protocol in order to communicate the data. An IP address represents an internet the protocol address, so it is a unique address that identify the device over the network and helps to improve visual communication between source and destination. An IP address helps to internet to distinguish between different routers, computers, and websites over the internet. Types of internet protocols, types of IP protocols. Internet protocols are of different types having different uses, which are TCP/IP. TCP means Transmission Control Protocol. IP means Internet Protocol. Second protocol, SMTP protocol, that is Simple Mail Transfer Protocol. PP protocol, double triple P, that means point to point protocol. FTP protocol, File Transfer Protocol. SFTP protocol, Secure File Transfer Protocols. HTTP protocols, Hypertext Transfer Protocols. HTTPS protocol, Hypertext Transfer Protocol Secure. Telnet, Terminal Network. POP3, Post Office Protocol 3. IPv4 version 4. IPv6, Internet Protocol version 4. Internet Protocol version 6. ICMP protocols. UDP protocols, User Datagram Protocols, IMAP, SSH, Go for protocols. These are all the protocols used over the internet while communicating from one device to another device. TCP/IP, that means the Transmission Control Protocol and Internet Protocol. So TCP/IP, Transmission Control and Internet the protocol was designed and developed by the Department of the Defense DoD in the year of 1916s, and so it is based on the standard the protocols which follow some standards. The TCP/IP model is a concise version of the OSI model. It contains four layers. TCP/IP model contains four layers, unlike the seven layers in the OSI model. The IP protocol, which ensures that each computer that is connected to the internet is having a specific serial number called an IP address. TCP, Transmission Control Protocol, which specifies how data is exchanged over the internet and how it should be broken into the IP packets. The TCP is also known as a connection oriented protocol. The packets have information about the source and the destination. Here, this is a TCP and IP protocol. Here, this is a TCP and IP protocol. It is a connection oriented. This is an example for TCP IP protocol. So, this is a source and destination. Registering the mail letters into mailbox. From that now, which is delivered to the letter to the receiver. That is the destination. So, like this is a connection oriented the communication. So, it's a best example, real time example for TCP IP protocol. Difference between the TCP and IP. The key difference says between the TCP IP or TCP stands for Transmission Control Protocol. It is a connection oriented and reliable protocol that is present in the transport layer. IP stands for Internet Protocol. It is a connectionless network layer protocol and is responsible for sending the packets to device in the network. The definition of between TCP and IP or TCP provides the service of exchanging data between the devices, between the application devices. IP handle the addressing and routing messages to the computer across one or more networks. The connection, in terms of the connection, the differences is TCP is a connection oriented and IP is a connectionless protocol. TCP protocol, IP protocol, in terms of location, the difference is transport. Here, the location is a internet. Reliability. In terms of reliability, it is a reliable. TCP protocols are reliable and IP protocols are unreliable. Transfer. Segment to the internet layer, datagrams to physical layer. IP transfers the datagram to physical level and transfer the TCP which transfer the segments to the internet layer. Flow control. TCP transmission, this which has the protocol TCP protocol, transmission control protocol, which has the flow control. IP which doesn't have the flow control. The format, in terms of format, TCP segments have 20 bytes header with greater than or equals to 0 bytes of the data. IP, in terms of IP datagrams which contain a message or one the fragment of the message that may be up to 65,535 bytes in length. Layers of TCP IP models. Mainly this TCP IP model which has four layers, that is application layer, transport layer and network or internet layer, network access layer. If you take OSI model, open system interconnection model, which has seven layers, that is physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Whereas in TCP IP model, which has four layers, that is network access layer. This is with network access layer now, which is combined data link and the physical layer. Instead of that now, which has only one layer, that is a network access layer comparing with the OSI model. Say network layer, transport layer, the application layer. Instead of these three layers, TCP IP has only one layer. So that is a application layer. It is physical layer. First, we'll discuss about physical layer. It is a group of applications requiring network communication. This layer is responsible for generating the data and requesting the connection It acts on behalf of the sender and the network access layer on behalf of the receiver. Data link layer. The packets network protocol type, in this case TCP/IP, is identified by the data link layer. Error prevention and framing are also provided by the data link layer. By using this the data link layer, we can transfer the data frames from one device to another device. That is point to point protocol. In this data link layer, we can use the point to point the protocol framing and Ethernet IEEE 802.2 framing are two examples of the data link layer protocols. Internet layer. This layer parallels the functions of OSI network layer, Open System Interconnection Network layer. It defines the protocols which are responsible for the logical the transmission of data over the entire network. The protocol residing at this layer are IP protocol, ICMP protocol, and ARP protocol. Here, IP protocol. IP stands for Internet Protocol. ICMP protocol. ICMP protocol stands for the Internet Control Message Protocol. ARP protocol stands for the Address Resolution Protocol. IP, Internet Protocol. IP stands for Internet Protocol and it is responsible for delivering the packet from the source host to the destination host by looking at the IP address in the packet header. IP, Internet the protocol, has two versions. One is IP4, Internet Protocol version 4, and IP5, IP6. IP has two versions. One is IPv4 and IPv6. Internet Protocol version 4 and Internet Protocol version 6. IPv4 is the one that most websites are using currently. But IPv6 is a growing as the number of IPv4 addresses is limited in the number when compared to the number of users. And internet layer. Here is ICMP and ARP protocols. Next, ICMP and ARP protocols. ICMP. ICMP stands for Internet Control Message Protocol. It is encapsulated within IP datagrams and it is responsible for providing the host with information about networking problems. ARP stands for Address Resolution Protocol. It is job. It's to find the hardware address of the host device from the known IP address. This ARP Address Resolution Protocol has several types, that is reverse ARP, proxy ARP, gratuitous ARP, and inverse ARP. Different types of this ARP can be categorized. That is reverse ARP, proxy ARP, gratuitous ARP, and inverse ARP. The internet layer is a layer in the internet protocol suite, which is the set of protocols that define the internet. The internet is responsible for routing of data or information from one device to the another device across the network. It does this by accessing each device with a unique IP address, which is used to identify the device and determine the route that the packet should take to reach the route. The transport layer. Fourth one, transport layer. The TCP IP transport layer protocols exchange the data receipt knowledge and retransmit the missing packets to ensure that the packets arrives in order and without errors. The packets which holding the information which is arriving in particular sequencing order or without without error these packets can be arrived end to end communication. That means here system to system communication, node to node communication. So which is referred to this transport layer. In this the transport layer establish the communication from one system to the another system. That is a end to end communication. Transmission control protocol and user datagram protocols are used in a transport layer. TCP and UDP. TCP, it is a transmission control protocol. These the TCP applications can interact with one another using TCP protocol as though they were the physically connected by the circuits. TCP transmits the data in a way that resembles the character by character the transmission rather than separate the packets. A starting point that establishing the connection and make up the transmissions. UDP. The datagrams deliver the service is provided by the UDP. The other transport layer protocol connection between the receiving and sending the host are not verified by the UDP. The applications that transport the little amount of data by using the UDP rather than TCP because it is eliminate the process of establishing and validating the connections. Application layer. The application layer is analogous to the transport layer in OSI reference model. It is responsible for end-to-end communication. That means system to system communication and error-free delivery of the data. The three main protocols present in this other layer are HTTP and HTTPS. So this is a first protocol. HTTP transfer hypertext transfer protocol. Here the first protocol is HTTP and HTTPS. HTTP stands for Hypertext Transfer Protocol. It is used by the World Wide Web to manage the communications between web browsers and servers. HTTPS stands for Hypertext Transfer Protocol Secure, that is HTTP Secure. It is a combination of HTTP and SSL, Secure Socket Layer. It is efficient in case where the browser needs to identify out forms, sign in, authentication, and carry out the bank transactions. All these the applications can be done by using these layers. That is a HTTP and HTTPS. So these by using these the protocols now we can perform all these the application, that is sign in application, authentication application, and carry out applications. Now carry out the any banking transaction, that is banking transaction applications. All these the applications can be done by implementing these the protocols, that is HTTP and HTTPS protocols, SSH and NTP protocols. SSH is a next second protocol. SSH stands for Secure Shell. It is a terminal emulation software which is similar to the Telnet, telecommunication network. The reason SSH is, that is a secure cell, is preferred in because of its ability to maintain the encrypted other connections. It set up a secure other session over a TCP/IP connection. NTP stands for Network Time Protocol. It is used to synchronizing the clock in our computer to one the standard time the source. It is very useful in situations like bank transactions. Assume the following situations without the presence of network time protocol. Suppose you carry out a transaction where your computer reads the time at 2:30 p.m. while the server reads it at 2:28 the p.m. That means the server can crash very badly if it is out of the synchronization. So this is a NTP host to layer. Here, what is a host to layer? Is a layer in the OSI model, that is a open system interconnection model, that is responsible for providing communication between host host to host over the network, computer to one computer to other computing device. It is also known as a transport layer. Some common use cases for the host to host layer are, so it is a reliable computer to computer the communication is a reliable data transfer, segmentation and resemble multiplexing and demultiplexing, end to end communication, reliable data transfer. Reliable data transfer, the host to host layer ensures that the data is transferred reliable between hosts by using the techniques like error correction, flow control. If there is any error between these, the transmission that can be corrected, and flow control can be done by using these reliable transfers. For example, if packet of data is lost during the transmission, the host to host layer can request that packet to be the transmitted to ensure that all the data is received correctly, and segmentation and reassembling. The host to host layer is responsible for breaking up large block of data into the small other segments that can be transferred over the network easily. By breaking up these large blocks of data into small other segment here, easily we can transmit the data from one device to the another device over the network, and then reassembling the data at the destination. This allows the data to transmitted more effectively or more efficiently and helps to avoid the overloading over the network. Multiplexing and demultiplexing. The host to host layer is responsible for multiplexing data from multiple sources onto a single network connections, and then demultiplexing the data at the destination. This allow multiple devices to share the same network connections and help to improve the utilization of the network. End to end communication. The host to host layer provides a connection-oriented service that allows the host to communication with each other end to end. That means system to system without the need for the intermediate device to be involved in the communication from end to end. For example, consider a network with two hosts A and B. Host A wants to send a file to host B. The host to host layer in host A will be break the file into smaller the segment. If it is a complicated, the file is a complicated now which is divided into smaller the segment for easy transmission and error corrections and flow controlling the information. Then transmit the segments over the internet to host to B. The host to host layer in host to B will receive the segment, check for the errors and resemble the files. Once the file has been transferred successfully, the host to host layer in the host B will acknowledge the receipt of the file to the host to A. Differences between TCP/IP and OSI reference model. TCP/IP model. TCP refers the transmission control protocol. OSI. OSI which refers the open system interconnection. TCP/IP uses both the session and presentation layer in the application itself. OSI uses the different sessions and presentation layers. TCP/IP follows connectionless horizontal approach. OSI follows a vertical approach. The transport layer in TCP/IP doesn't provide assurance delivering of the packet to the destination. In the OSI model, the transport layer which provides the assurance delivering the packets to destination effectively. Protocols cannot be replaced easily in TCP/IP model. While in the OSI model, the protocols are better covered and are easy to replace with the technology change. TCP/IP model network layer only which provide the connectionless, that means the internet protocol service. The transport layer TCP provides the connections. Connectionless and connection oriented service are provided by the network layer in the OSI model. Network access layer and a link layer. Network access or link layer which specifies the physical the transmissions of data over the network. This layer handles the data transmission between two adjacent devices on the same network. It also which determines how bits should be optically signaled by hardware devices that interface directly with a network media such as coaxial cable, optical cables, fiber cables, or twisted pair cables. Highlights or TCP IP. First, in application layer, if you take the application layer is responsible for node to node other communication. That means system to system communication, which are open, controls user interface specifications, HTTP, SMTP, Telnet, etc. are some of the essential other protocols. Host to host specifies how much data should be sent, when and where at what rate. TCP and UDP are two significant protocols of these layers. The internet layer primary function is to sending the packet from source to the computer to their destination, regardless of this router. IP and ARP RT are the two significant protocols of this layer. IP and ARP are two significant protocols of the layer. Network access layer, which handles the data transmission between two adjacency devices on the same network. Advantages of TCP/IP protocol. It is a set of open protocols. As any one of the institutions does not own it, it can be used by anybody or any group. It is a client server architecture and highly scalable. It allows the addition of new network with disturbing the existing services. It is an industry standard model that can be used to solve the real world networking problems. It is an industry standard model that can be used to solve the real world networking problems. It is interoperable, allowing two different other systems to communicate via a heterogeneous network. It assigns a unique IP address to each device in a network such that each device has its own unique identity over the internet. It is challenging for human to remembering numerical values compared to the alphabetical names. So to solving this, TCP/IP models also provides DNS service to provide resolution between the alphabetical domain names and IP addresses. Disadvantages of the TCP/IP model. The concept like services, interfaces, and protocols are not distinguished. As result, describing new technology in a new network is not appropriate. This model was created to be used in a wide area networks. It is not designated for the tiny networks such as LAN and PAN, pervasive area network. That is a personal area network. It is not PAN means personal area network. It is not generic. As a result, it cannot be represent any protocol stack other than TCP/IP. It cannot, for example, here define a Bluetooth connection. It is not easy to replace the protocols. TCP/IP stands for the conclusion of the TCP/IP is TCP/IP stands for the Transmission Control Protocol, Internet Protocol, and is a shoot for communication protocol that makes data exchange between two devices possible. TCP specifies how applications are established, network other communication channels, and manage flow and error control. It also has an acknowledgement function, so which increase the overall reliability. And it IP specifies how each packet should be addressed and routed to ensure that it is arrives at its destination. There are generally four layers in TCP/IP protocol, but extended to five in some cases. The four layers of TCP/IP are the application layer, transport layer, network layer, and data link layer.
Like, share, and subscribe. Hit the bell icon for more updates.